What's good, guys? What is it? What's good, guys? Let's get into the leak code. I think it's 192 or 3 or something like that. So the problem I solved is this one. Now let's a hard that's 70%, 69%. That is a little scary, but not at the same time. It means it's not bad. We'll see though. You have k lists of sorted integers from non-decreasing order. So it's increasing. Fucking, I hate when they word it like that. Find the smallest range that includes at least one number from each of the k lists. We define the range A to B is smaller than the range C to D. If B minus A is less than D minus C, okay, what the hell is this? You have okay. Smallest range that includes at least one number from each of the k lists. We define the range is smaller than C, D, B minus. Okay. This one's hard. Okay. Let's see if I can understand this. We have 4, 10, 15, 24, 26, 0, 9, 12, 25, 18, 22, 30. We say 20 to 24 because 24 is in the list. Okay. It has to be a 2-element list, right? I guess getting the minimum and the maximum. How would this be sliding window? This is a complicated question. 1, 1, 1, 1. They all share 1. I can see like a frequency type of thing. Like we can, it's 22 because that's in the range. So this is a range essentially, right? Okay, doesn't smallest range covering the elements. Oh. So we have to build out. So basically find the smallest element here. Why 20? What was the... $20 is in the range 20 to 24. 22 is in the range. I guess we can start with the smallest list from, like, the smallest value in the list. Like, check the biggest value. Check if the value is in there. We define range AB is the smaller range than CD if B minus A is less than, okay, or A is less than C and B minus, okay. Damn, this is a hard problem. Smallest range covering elements from K-list. What we can do here is like, do I take like the frequency? List 1, list 2, list 3. Okay, so it's basically a range is smaller if like the range itself is smaller. So it doesn't matter if, like, I could have 1 through 10, but that's actually a bigger range than this, because even though the numbers are smaller in the other one. So I just care about minimizing the range, right? The range here is 1, 1 here, because there's at least a 1 in every single list. Because I mean, I could do 1 through 2, but yeah, that's kind of what I want to start with, is just get the smallest number. Like, okay, smallest number here is 4. Anyone 0? No, can't, because there's something smaller, right? Oh, we could have like, we know that it's ascending, so we know that we know the smallest values. The smallest value is 405. We'll just pick 0, right? Then we go on 10, 9, 18. And the biggest number is 26, 20, 30. Find the smallest range that includes at least one number from each of the lists. This is kind of hard. I'm kind of stuck. Let's see. Greedy, sliding window, and then we can sort or priority queue. I can see, like, we want to maximize what? We want to maximize the distance between the two. I guess the smallest number in the entire thing would be 0 to 30. Basically, we want to increase, like, definitely want to, we want to, do, like, okay, so for the first one, we have the smallest is 0 to 30, right? And we want to increase it to, we want to minimize it as much as we can. So, like, the next one, like 1 to 30, would that satisfy still? Yeah, it will still, and it will keep going till, like, one of them is bad. So we'll keep going, and it would be probably all the way to 20, right? Or let's try, like, 19 is valid, and then we keep going 20. And then let's do 21, and then I think one of them fails. This one, this will not be in the list. So that is the smallest one we can do, right? Now we want to, this is the smallest range that I can have, and then 30 is very, like, everybody is included in 30. Like, we have a number that at least is like, this is there, 100, all of these will be fine. So let's try to make it small as possible, but not until as small as possible. So 29, can we still have 29? Yes. 28. Yeah, 28. 27. Yeah, we're still good. Yep. Let's try to do 22, right? I mean 23. I think this will fail because there's not, well, actually this is still fine, but this would fail because there's no number that's going to be in the upper bound. Well, actually it has 20, so it's fine, but this would fail because it doesn't have any number, you know. So yep, it'll be capped. So 24 is the cap. So yeah. That's kind of what I can think of. Start with our largest ends and then try to increase and decrease until it fails. So I'm praying that there is not duplicate numbers, but I don't think that matters. So we can have like some kind of like we'll have res like this, right? Whereas the min and max like this, right? But we obviously need to calculate that. So let's do this. Min, max, float. So the minimum should be the biggest number possible. Negative infinity. And then we need to iterate. So for every item L in nums, the minimum min of min or the list. Do the same but for max. I'm gonna just see if I get this right. So let's print the res. Oh, I gotta call min again. It's okay. Beautiful. This is exactly what I wanted, right? Then we will start increasing and decreasing. I also want to convert everyone into a set. So maybe doing I is better. Oh, let's do this. Let's be Pythonic here. Let's do enumerate. We'll do I and L and nums of I equal a set of nums of I, or not even I, we could just say L, you know. Let's also print nums and res. So let's show that. Kind of like preparing the enumer. Yeah, there you go. So yeah, so we can have yeah, beautiful. Because we don't really care about the sorted. I mean, I guess there probably is a reason why it's the sorted part is useful, but whatever. Okay, so basically, let's just increase res of I or 0 like this while it's true. I don't know the condition yet, but we'll figure that out, right? And while something like this, right? Also, yeah. Find the smallest range that includes at least one number from each of the K lists. So like, yeah. We increase. When do we stop? This is gonna be really bad time complexity. For every L in set in nums, if S or if res of this in S not in, then we should probably break out, because that's the break, and probably undo what we just did, right? But otherwise, we'll do this. This is very inefficient. I don't even think this is sliding window, but I can't really think of the sliding window, so I don't know. We have to increase because that was too big, and then decrease. This is so disgusting. But I mean, let's just try, I guess. Probably got a Chile, to be honest. No way we get TLE on the freaking dummy test, like the examples. Wow. Does it really take that long? What? Oh my god, we're cooked. This is like freaking n factorial or something. I don't even know. This is pretty bad. I mean, did it even run? Like, does it even work? Or like, take the smallest value here. What if I take the smallest value? Smallest value here. I don't know. I think I give up, guys. This is way too, like... let's see. 2-pointer sliding window. Okay, it's to have a freaking heap. Okay, so we take the heap while it's there. Damn. Binary search. Heap concept. I want to see a sliding window. Alright, why is this guy so excited? Whoa. So merge into with index, okay. Then sort by number. Okay. Count. Total list. Unique list in a window. Min range. So for every R, count. Wow, that. This one's kind of interesting. Let me try to understand it. We first merge all the numbers from different lists into a single list of tuples where each tuple contains the number and the index of where it came from. Sort the merged list by the number values. Use sliding window to ensure that each window contains at least one number. Track how many numbers from each list are in the current window and adjust windows left and right to minimize range. Oh, damn. Okay, so we merge, count, min range in all nums. Count of all nums are 1. If equals 1, then unique list. This, I need some more conception. Like conceptual explanation. This is a bit confusing. Dude, this is crazy. All of these are fucking complicated. Why is this a 70%? I'm just stupid, bruh. I don't know. I can't. This is a hard one. I can't really understand it conceptually. Maybe I'll try it again tomorrow. Sliding window technique. Easy approach. Let's see this one. So we take... Right? Sword. While all result... Damn. I don't know. I have to take that on this one. Conceptually, I'm not understanding it, so I'm gonna probably take some time on my own, try to understand it, and then we can try it again tomorrow. But anyways, thanks for watching. I'll see you tomorrow. Peace.